Okay, good morning, everybody. It is 7:56 Monday morning. All right, I'm here to finish up the rest of your guys' first week of assignments here. Okay, so hopefully everybody's doing okay. Make sure to try to get yourself in some sort of routine. Okay, routine is good. We don't have a real routine going on, at least for some of you guys, so it's important to try to build some sort of structure in your day. All right, so whether or not you decide to do your math homework at 4 in the afternoon, or whether to take care of it during the afternoon, those are clearly your choices. But you need to make sure that you're not just sitting around, and make sure you're staying on top of your studies, okay? Because it's important to make sure that you guys are staying in practice. You're not, not losing all that work that you guys put in, all that time for to, try to pass this Regents and all your other courses. So just make sure you guys are finding some sort of routine, something to keep you guys busy, because otherwise you're going to start finding yourself slipping. So anyway, that's just my little spiel. That being said, let's get started. Okay, so this is day 3. All right, number 11 in your polynomials section, okay? So we're talking about Miss Allard, right? Number 11, right? Miss Allard asked her students to identify which of the polynomials below are in standard form and explain why, okay? So here's our 3 choices, and then these students gave a response, and we have to decide which one of these is the correct one, right? And so I want to take a look at these 3 problems here, okay? I want to discuss what it means to be in standard form. Okay, so standard form for quadratics, at least, okay, because we've already just started discussing those, looks like this, all right? And they call it standard form because, first off, how many x's do you see here in that first term here, okay? Maybe we see 1, but technically it's 2, right? Right, x squared. Okay, how many x's we see here? We just see 1. And how many x's we see here? We see none. Okay, this also represents our degree. Okay, so our degree measure in that first term is 2. Our degree measure in the second term is 1. And our degree in the third term is 0. And remember, any constant, its degree measure is 0. And let's just take the constant 5, for example. We don't see an x located next to it. All right, so because we don't see an x, therefore its degree is 0. If we had 5x, our degree would be 1. If we had 5x cubed, our degree would be 3. And don't forget, if for some reason there was an extra y there, our degree measure would be 4, okay, because we'd take the 3, we'd add with the 1 next to that y, even though we don't see it, right? Anytime you just see like y, that is y to the first power, right? How many times is y being multiplied by itself? Once, okay? So just keep that in mind when you're solving these problems, all right? So this is what it means to be in standard form. So our degree measure goes from largest to smallest, okay? So if you look in this one right here, let's take a look at the third one, okay? It goes 5, 2, and 1. Okay, those are our degree measures. Take a look at number 2. It goes 3, 1, and 0. All right, so far, these two, all right, are in standard form because our degrees are going from highest to lowest. But then if you look at the top one, it goes 4, then 1, and then 2, and 0. Okay, so you can see our degree measures aren't going from largest to smallest in that first example. So therefore, right, anything that has a 1 in it is out. Okay, now this one doesn't have 2 or 3, it just has 2, so that one's out. So we're just left with 3 and 4. All right, so now we have to decide whether or not which one of these guys is right, and whether it's Fred or whether it's Alyssa. So Fred says 2 and 3 because the exponents are decreasing. And Alyssa said 2 and 3 because they each have 3 terms. Okay, so let's correct what Alyssa has to say. Alyssa is wrong because we could have something written like this, right? That's in standard form. Our degree measure is 2. Our degree measure is 0. It goes from highest to lowest. And this only has 2 terms. So Alyssa is wrong. So our answer has to be 3. Okay. That's number 12. Number 13 says, which expression is equivalent to 18 squared minus 50? All right. Now, a couple ways you could go about this. You could plug in a value for x and plug in a value for all of these other x's, multiply that out, and see which one of these comes out to be the same answer. That would be the long way. Okay? What we're going to do is we're going to factor this expression. Right? What I mean by factor is I'm going to split it up so that when I multiply these two factors together, they multiply to get to the same, get you back to the start. Okay, that's what it means to find factors. So when I say the factors of 32, I say 4 and 8. Okay, I say 16 times 2. Right? And I say these numbers because right, when I multiply 4 and 8, right, when I say they're factors, when I multiply these together, they get me back to 32. Okay, so that's what it means to find factors. What could I split this up as? So when I multiply those two pieces back together, get you back to the original. All right, so talking about factoring. Anytime we're talking about factoring, you always want to look to see if you can find a GCF. Okay, and our greatest common factor. But what I mean by that is there's something that can divide into both pieces, right? So I can divide both of these pieces by something in order to make my numbers a little bit smaller. Okay, so I don't want to divide technically. I don't want to just like get rid of it, but I want to factor it out. All right, so what can divide into both 18 and 50? Right, now they're even numbers. Okay, so all else fails. If you can't think of what the factor is at first, try to take out a 2 first. By taking out a 2, right, it's a safe bet, okay, and you're also making, I mean, you're still factoring, you're making the number smaller. So 18 and 50, I'm going to take out a 2 at first. I'm going to see what that does. So when I factor out a 2, so I divide 18 by 2, I get 9x squared, and then 50 divided by 2 is 25. Okay? So, it doesn't look like any of our answers yet, so we must still have a little bit of work to do. Now, if you haven't recognized it yet, okay, let's take a look at some of these numbers here. So this is some numbers squared. 9 is some numbers squared, and then we don't know what this number is, but it's being raised to the second power, so this is some numbers squared. And if you notice in between, we have a subtraction sign. So what this means is we have a difference of 2 squares problem. All right, so don't forget our perfect squares are 4, 9, 16, 25, 36, 49, and it keeps on going, okay? I'm focused on these two right now. So 9 is actually just 3 times 3, and 25 is 5 times 5. So I'm going to split these up. Okay, put an x on both sides. Put a plus or minus in between. In the front here will be a 3, and in the back will be a 5. And that's what it means to split up your difference of 2 squares. And if I were to multiply these two, if I were to multiply these two pieces together, okay, and then multiply that 2, you should get the same thing back there. Okay, and so do we see that answer? We sure do. That is number 3. Okay. Let's take a look at 13. So the expression x squared minus 10x plus 24 is equivalent to what? Okay, so again, just like this one up here, all right, when it says what is equivalent to, they want you to try to factor this thing, okay? Now, you could cheat and just plug this into your y equals, all right, and plug all those others into your y equals and get your table of values, okay, and see which ones match up. That's one way of doing it, but it's a little lengthy, all right? Then you got to type everything in. I think it'd be a lot less time consuming to just try to factor this thing. So this is just an expression, right? We don't have an equal sign in there, so anytime you have an equal sign, it makes it an equation. This is just an expression. And so we're trying to make it look like one of these 4 options. Okay? So in order to do that, we need to look at the factors of 24. Okay? So your easiest one is 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay? Those are our factors of 24. And now, in order to factor this thing, I need to come up with 2 numbers that add up to negative 10, okay, but multiply to a positive 24. So I need 2 numbers that add up to a negative number, but then multiply to a positive number. So what that means is both of our numbers are going to have to be negative. Okay, and the only numbers that either add up to 12 is this and this. And if I add both of these negative, it would be negative 14. This gives us negative 10. Okay, so it would have to be negative 4, negative 6. So x minus 4, x minus 6. And do we see that answer? We sure do. That is number 4. Okay. Let's take a look at number 14. Now 14 is a bit tricky in a sense that we haven't really covered a problem that looks specifically like this, but I don't think it's too hard to just show you guys what it is that they want. So again, we're looking for an expression that is not equivalent to this one on the top, which means that 3 of these are going to be equivalent to this expression right here. So one of these is not. All right? And so what we're going to do in order to find that is simply just distribute these numbers on the outside. All right? So when we multiply these numbers out, okay, so we'll have to multiply this one out here. Let me, oh crap, give me a second. Put that up there, there we go. Okay, it's like this one here, you'll have to do your arrows, okay? This, all right, so that's what we're going to do for all of these. And we're going to see which one of these does not get this expression back here, okay? So let's take a look at this first one. So when you multiply this, when you distribute, okay, we're going to get a negative 4x cubed plus x squared minus 6x plus 8. And is that what we have up in the top there? Sure is. So 1 is out. Number 2, same thing. I'm going to distribute across, so I'm going to have a negative 4x cubed minus x squared plus 6x plus 8. Again, I have exactly what we have up top, and that one is out. Let's take a look at number 3. Okay, so we don't really have anything to do with that one, but we can multiply this out here. So here's our arrows. All right, so it's going to be plus x squared minus 4x minus 2x plus 8. And you combine like terms here. You get negative 4x cubed plus, x squared minus 6x plus 8, which again is exactly what we have up top there. So that one's up. So it has to be 4. Right? And 4 is the answer. All right? I'm going to keep you guys waiting, hanging on the edge here. All right? 4 is the answer. Okay? And so if you were to multiply, or I'm trying to multiply, well, you're multiplying, but distribute those two numbers on the outside, you would get negative 4x cubed, okay, plus 8 plus x squared minus 6x. Okay. So one of these is not. Oh, hello, McFly. Jeez, missed that one. My bad, guys. The answer is 2. Holy cow, how did I miss this guy right here? Alright, as you can see, I make mistakes too. I'm looking at this one over here, I'm like, well, we got a negative 6x. Okay, so it's not 4. It's not 3. It's not 1. Alright, it has to be number 2 because we don't have this negative 6x. I'm sorry, if you guys have been watching this and already spotted that, I apologize. Okay, so I missed the negative 6x there. My bad. So 2 is the correct answer. Okay, this one is not equivalent to this one up top there. Okay. All right, number 15. This will be the last one for day 3. So which polynomial has a leading coefficient of 4 and a degree of 3? All right, so in order to start talking about leading coefficients, okay, and degree measures, we got to have these things in standard form. So again, standard form looks like this, okay, where our degree measures, which are counted by our exponents here, go from highest to lowest. Okay, so that's what we want to do first. We want to make sure these things are at least written in standard form before we can start talking about leading coefficients and degree. Okay, so this one's good. All right, 4, 2, 4, 2, 1, 0. Okay, those ones go in the correct order. I'm looking at this one down here. All right, let me put this one in the correct order. So it's going to be 5x cubed minus 4x squared plus x plus 4. Okay? All right, so now this one's in standard form. Let's take a look at number 3. 4, 3, 2. Okay, that one's in standard form. And this one is not, so we're going to have to adjust this again. So it's going to go 4x cubed plus x squared plus 2x. And now our order goes 3, 2, 1. Okay, so now, because they're all in standard form, okay, we can start picking out which one has a leading coefficient of 4 and a degree of 3. All right, so leading coefficient of 4, what that means is the first term, okay, when in standard form, okay, you're looking at the first term, so it has to be in standard form first. And then that number that appears in front of that highest degree measure, in this case, like I said, they're all in standard form, so your degree measure should go highest to lowest. Okay, so when you have them in standard form, you look at that first number, all right, and that's what we talk about leading coefficient. All right, it's the number that's attached to that highest degree. All right, and so we're looking for a leading coefficient of 4. This one I see a 3 and a 5, so those two are out. So now we have to look at these two right here. We're left with 3 and we're left with 4. All right, so clear up some space here. All right, and so now degree of 3. So what we're looking at is what is the degree of the polynomial, and the degree of the polynomial is always the highest degree you see in each of these. All right, so in this case, your highest degree measure should always come in the front, okay, because it's in standard form. So this one is 4, and this degree measure is 3. So we have a degree measure of 3, leading coefficient of 4, and so our answer, put it in a different color, is 4. Okay, and that concludes day 3 for the polynomials. All right, stay tuned. Hopefully you guys are finishing up your homework here, at least somewhere between yesterday and today, and so be sure to be checking your answers.